Let's begin. So today I'll talk to you about the integration of Incus into Bareos. So I will introduce a little the subject. I will talk about Incus, obviously, because, well, I guess some of you don't really know what the project is. I'll tell a bit the history of how we got there, and then how the plugin works, and then a few closing words at the end. So, as an introduction, just a few words about me. Not a lot of things, but so I work at IMT Atlantique, which is a French technological university, and at work, well, we use Incus quite a lot, and because we use it quite a lot, I eventually became a maintainer because I contributed to the project. You can find me on GitHub, SMRS, usually with my cat's picture, but on some other networks you can find my actual picture. So what I do in this university is that I manage the IT infrastructure for the computer science department. It's quite a modest infrastructure, honestly. We only have like a dozen servers, but, well, we don't have that many VMs or containers either, but we have quite a big internal network, and we manage a lot of data, actually. So we have a 100 gig internal network, and we have a good 1,000 terabytes of data. And, well, I'm involved in quite a few open source communities, and I started looking at Bareos last November. And, well, I'll talk to you a bit about how I got there later. So the big picture of this presentation is that we are using Incus a lot in our infrastructure. The problem is, as it is a developing project, it's not supported by big enterprise-grade backup solutions, or at least it wasn't. And, well, I had the need to back up the whole infrastructure. So if it doesn't exist, well, it's open source, so you have to do it yourself. So I did it. So first, I'll talk to you about what Incus is. I'll show you the big facts about Incus, and I will do you a little demo so that you can have a quick feeling about how it all works. So, what is Incus? It's a VM, system container, and application container manager. You may have heard about LexD, which is a Canonical project. Incus is a community fork of LexD. It started in 2023. And yeah, it's led by the community and by the former maintainers of LexD. And it's a growing community, but it's already quite impressive, I think. So during the last year, we've had a bit more than 200 contributors, and we have more than 250,000 users all over the world, mostly in Europe, but, well, we can find users in almost every continent. So yeah, it's still a young project, but it's the fork of quite an old project. And during the fork, well, most of the users followed us, and, well, it's quite nice. What makes Incus a bit different from other hypervision tools like Proxmox or VMware or the others, is that it's the same tool that you install on your laptop and in your data center. So basically, I'm doing the presentation here on my laptop, and I have Incus running on my laptop, managing some virtual machines and containers. And it's exactly the same piece of software that I have at work on all my servers and to manage my virtual machines and containers within a cloud cluster. So you can install it basically everywhere, and we have several kinds of use of Incus in the wild. So some people use that to build their own build infrastructure. So for example, in Debian, there's a big project of reproducible build infrastructure. And basically, Incus manages that. So you spawn a new VM or a new container to build your packages, and everything is managed through Incus. We have large-scale cloud clusters. So we have people running Incus in hundreds, and I think there are a few people running it with thousands of servers in clusters. And we also have people just running Incus locally to have isolated environments. So the same way that you would use Docker locally, people use Incus. And so Incus is made of the tool that manages virtual machines and containers, but it also has a nice API, a CLI tool, and well, everything is abstracted so that you can manipulate storage network without really taking care of what's behind. So yeah, it's pretty nice in that regard. We have 3 release channels for Incus. So if you're adventurous, you can try the daily unstable releases, which no one does except for developers. So don't do that. A lot of people are using the stable monthly releases, but most folk are using the LTS releases, which provide more guarantees. They come out every 2 years with bug and security fixes that are backported. And we've had, at the beginning of May, we had our new LTS version released, so Incus 7.0. So that's a good new version. So if you're trying Incus, you will probably deal with Incus 7.0, which is the latest release. I'll give you a few technical details. I won't go into much detail, but I think it's quite nice to know if you're interested in virtualization technologies. So Incus is able to run virtual machines and containers. If you can run Linux on your machine, you should be able to run Incus and run Incus containers. We have a more limited support for virtual machines, but it's already like a nice nice support, because we support virtual machines on x86, Arch64, PowerPC, and S390X, so the IBM mainframes. Storage-wise, we support the big players, so Btrfs, LVM, ZFS, and in clustered storage, we support Ceph, Linstore, and TrueNAS. So yeah, we have quite a few users of these, and basically, if we have enough users asking for support for a new storage engine, then well, we will commit to it. Network-wise, basically everything that you expect from a virtualization engine. So we support a big variety of networks. We support hardware offloading. We support open virtual network. So yeah, but there are plenty of boring details. That's just like the whole the big picture of Incus, virtualization-wise, storage-wise, and network-wise. So I will give you a very quick demo so that you can see how we usually interact with Incus. And after that, we will come back to like the core of this presentation, which is the link between Incus and Bareos. So let's look at a nice tool, which is the command line. So basically, the easiest way, I think, to interact with Incus is through the command line. So you can just spawn a new container. Let's say that I want Trixie virtual machine, Debian Trixie. So I can do Incus launch images, Debian Trixie. I'll call the machine test, and that's it. So it's launching a new container, which is called test, and I can run a shell and access my container. Incus shell test. And then I'm within my test container. I can do whatever I want in it. And well, obviously it's a new container, so most of the tools are not here. And yeah, we have a nice command line tool to interact with it. And we also have several people developing web interfaces. And well, the most common web interface is basically a rebranding of LexD's web interface. Obviously, I'm doing this presentation outside of the network that I prepared, so you won't be able to see the web interface. I'm sorry. But yeah, you can do plenty of things with it. You can run Linux, obviously. We have support for Windows virtual machines. We have limited support for macOS guests. And we also have support for FreeBSD virtual machines. So for example, I can launch a FreeBSD 15 virtual machine. And after it has started, I will be able to access it. And well, we have plenty of other tools that are quite nice within Incus. So I really encourage you to try it out if you are looking for a lightweight solution to replace your commercial tools. Then Incus is quite nicely suited for that. And we have quite a few people that migrated from VMware to Incus. And we provide also tools that help doing this. If the virtual machine has started, I can show you that you can directly access the files within your instances. So for example, here, I'm editing a file within my FreeBSD virtual machine. So yeah, it's quite a nice tool. We can also discuss that after the presentation in the questions and answers if you want. So that was it for this quick demo. Now I'll talk to you about how we came to this. So initially, well, our infrastructure is backed up, obviously. The problem is that our backup infrastructure was made entirely of hard drive disks. And well, hard drive disks have this tendency to fail after a few dozen thousand hours. And well, as you can see in this slide, some of our disks had more than 60,000 hours of operating time. So we thought about replacing them. But as you know, hardware is getting more and more expensive. So yeah, the price of hard drives was getting quite high. And we look back at the price of tape and the price of tape drives. And well, it started being quite interesting to us, given the volume of data that we wanted to back up. And so we bought a tape autoloader, and we bought several tapes to perform our backups. And also, I always wanted to have fun with a tape autoloader. So yeah, we bought that. The problem is we bought it before having a clear idea of the backup solution that we wanted to use. To understand our need, you need to understand like our infrastructure, because we have a very versatile infrastructure. We have employees that need to back up their data. We have several servers that we need to back up. We have our PhD students that have a lot of data to back up. So basically what we do is daily backups of our servers. Our employees can decide to back up their laptops. Our PhD students have tens of terabytes of data that they might want to back up because they make mistakes, and then we have to restore their work. And we also have software artifacts that are built by our teams. And well, we like archiving, so we would like to provide long-term archiving for all the software that our teams write. And so after studying the market, I'm a huge free and libre open source software guy, so I did not even look at the commercial solutions because that's not what I want for my infrastructure. But basically, there were only two pieces of software that were able to, well, that advertised being able to handle tape drives properly. Proxmox Backup Server and Bareos. So that was in October. And well, in October, I decided that I wanted to attend a conference in southern France, which is called the Capitale du Libre. And well, I saw in that conference that the very tool that I was interested in was presented by Bruno Friedman, and well, we discussed a lot with Bruno, and I became quite convinced that it would be a nice thing to have in my infrastructure. So we started discussing in November. I opened the discussion on GitHub. I proposed an initial implementation in January. We've had a lot of back and forth reviews, so that lasted for 3 months. And well, now it's merged. So it will be released in the next major Bareos version. So yeah, and I also want to implement a few more things until the next version. So there's also that. So that was the whole history of it. I will present you now how it works, what I really needed in this plugin, and well, the technical details of it before concluding. So basically, what I wanted to do is to have full and incremental backups and restores. I wanted the plugin to support both containers and virtual machines. I also wanted to be able to backup and restore on servers that had very constrained resources. So for example, we have a few servers that have more than half of their storage occupied by a single instance that we want to back up and restore. So I cannot really handle having temporary files because, well, this server has a 20 terabyte hard drive, and the VM that I want to back up is 12 terabytes. So I can't have a temporary file growing over 8 terabytes. So that was a huge no-go. So all these requirements actually were quite hard to handle, but well, we studied that for quite some time and came up with the solution that is now merged. So basically, when you backup files for a container, Incus, you can ask Incus to produce a tar file, and this tar file is backed up. So we stream the tar file to the plugin, file by file. We transform every file into a file that Bareos is able to understand because, well, the way Bareos stores its data is quite different from the way a regular tar file stores its data. So that works quite nicely because, well, a tar file is quite a simple data format. You have all your files that are streamed, and the files are not interlaced. Like, you have clear boundaries between the files, and you can just give that to Bareos in a single stream. So there's nothing, no temporary file created. It's direct between Incus, the plugin, and Bareos. Now, for virtual machines, it's a little trickier. For virtual machines, if you have a big hard drive, let's say several hundred of gigabytes or even terabytes, if you store the whole disk as a single file, you'll have some trouble performing incremental backups, because if you modify only a single byte in your whole disk, well, the disk has changed. So what I came up with is a way to cut the disk into chunks of data. And as the disk image is being streamed by Incus to the plugin cuts chunks of data, computes a hash, and sends that chunk to Bareos. And when performing incremental backups, Bareos can compare that hash with the hash it has in its database. And if the chunk of data has changed, then we only back up this chunk of data and not a whole disk. So that allows to have native deduplication, because we only perform like incremental backups over our disk images. So that was something very important for me, because we only have a limited amount of tape drives. So we bought like 200 terabytes of tape drives, but we have a lot of data to backup. So we don't want to every day have to backup tens of terabytes of data. We only want to back up the differences, and let's say twice a year, maybe do a full backup. So that was the way to implement it. For restores, it's the other way around. So for containers, we take the files that are stored in Bareos, we convert them back to tar streams, and we populate a tar archive from these files, and we send that to Incus. Again, in a single stream of data. No temporary files. It goes straight from Bareos to the plugin to Incus. Now, for virtual machines, it's a bit harder because, well, when you perform incremental backups, Bareos restores the files in the order of which they were inserted in the Bareos database. So it means that you can get chunks of data which are unordered. So the plugin has to be a little more clever with that. It has to reorder the different disk chunks when performing incremental backups. Well, restores of incremental backups. So yeah, that was the hardest part of the plugin. And this part actually requires some temporary files, because if you're reconstructing a big disk image, then you have to have a temporary file to put the disk chunks to reorder them and then send them back to Incus. So yeah, so that's the way the whole plugin works. there's no, I mean, it's quite obvious if you look at the big picture. Like, you want to back up disk images, you cut them into smaller chunks, etc. But the whole implementation was a bit tedious, and there are plenty of tests to try to find all the issues that could arise in this process. So I will conclude this presentation first by talking about my experience contributing to Bareos, and then talking about the future work with this plugin in Bareos, and also in Incus, because contributing to this plugin has led to changes within the Incus code base, because we found out that some of the things that we were doing were not optimal. We were creating temporary files where it was not a good idea to do so. Contributing to Bareos, I found out that, well, you guys have very high quality standards in the critical code path. So as soon as there is some concurrency issues, then all the reviews were very thorough, and as a future user of Bareos, because I'm still setting up the infrastructure, well, it makes me quite happy, because, well, I know that the software that I will be using is quite safe in that regard. And I've had the occasion to have very nice discussions with people that helped me with this project. So that was a very nice experience, and I'm looking forward to continue working on this plugin. About that, so for now, with this plugin, we can only back up virtual machines and containers. Well, if you're using Incus, there are a few other objects that you would like to back up. So Incus is able to manage storage volumes, which are not directly attached to virtual machines. It manages key value buckets. It manages operating system images. So these are things that I would like also to be able to back up in Bareos. Also, backing up the server configuration is also another short-term goal for me. And we have several things that are a bit more technical. I will not be talking about dependent volumes, because if you're not an Incus user, it's not something that will really mean anything to you. But there's a limitation currently in the plugin. It's that you can only perform full backups and incremental backups. What I mean by full is that you can only back up the whole disk or the whole file system of your container. So another goal for me is to be able to only back up a part of a container, like only a subdirectory, and being able to restore only that. And Incus provide an SFTP API to be able to do that. And a very long-term goal is to be able to restore only parts of disk images. So Incus provides another API which uses the NBD protocol. So that's something that I would like to see implemented. And I think NBD is already used in Bareos for, if I remember correctly, the VMware plugin. So there's also something to do around that. And in Incus, developing this plugin has allowed us to find a few issues. So in the short and medium term, we would like to modify a little bit to Incus to reduce the amount of temporary files that we create, and to improve all of our import and export mechanisms. So yeah, that's it for me. I hope you enjoyed this presentation, and I really hope that you will try out Incus, because I think it's a really nice piece of software, and it's also quite good to replace other commercial products that may cost you a lot of money. So it's always nice to use more open source tools when you can. So yeah, that's it for me.
Yeah, thank you very much for your presentation. Very interesting. And thank you very much again for this great contribution. We really appreciate this. And yeah, I think that as many organizations and companies which are using VMware due to the acquisition of Broadcom and the changed pricing policies are looking for alternatives, and Proxmox is very popular here, but I'm really happy that we see another alternative here with Incus. And yeah, any questions? So questions can be asked either in the chat. Just use the speaking bubble symbol to open the chat tab side on the left side, or just unmute and ask something.
You said Incus had some support for macOS guests. Is this only on macOS hardware, or can you also do that on a normal Linux machine?
So, do you want the official legal answer? Legally, you can only run that on Apple hardware. Well, I was responsible for this. You could. I'm not saying I am. You could be running macOS guests on Linux with regular hardware. It only works on x86 because currently the community to virtualize macOS has not really been focusing on the new ARM architecture, but yeah, for me it was a nice side project to learn a bit more low-level stuff. It's not really something that I would recommend in production, but I use that as a learning tool to know more about Incus, its code base, and to gain some competence about virtual machines. So, but it works.
Okay, great. Thanks.
Can you maybe also shortly explain why Incus has been forked from LXD?
So Canonical changed the licensing of LXD and required contributors to sign a license agreement, a contributor license agreement. This is not something that people were happy with. So basically, all the former maintainers of LXD decided that no, it was not a good idea, and they built Incus.
So did I get that right? So when backing up containers, then the plugin processes the tar file, and in that case, it in Bareos there are files which are then so if you do a list files job ID equals and then the job ID number, then you see all the single files. So
yeah,
theoretically, you could restore single files from container backup.
Yeah, theoretically. The only thing that's missing is a way for the plugin to tell Incus only restore this. It's not that hard. It's just that it was not in my initial. Well, I did not need it actually. So it would be nice, but I don't need it.
Yeah, I think the challenge is to restore it back to an existing container, right? I mean, you could just select a different restore client and restore it there and then copy it over, but that's probably a bit too complicated. But yeah, good to know that it's generally possible. Yeah, any other questions?
Yeah, one question about the backup of virtual machines. So you say you are using blocks and hash is calculated for them. Is this hash calculated by Incus independently, or is it something you implemented in the plugin? Or
so it's the dark magic part of the plugin. It's mostly a hack. So what I'm doing is so first it only works with Bareos in accurate mode. So what I'm doing is that I'm cutting chunks of data. I'm computing a hash. The plugin itself computes a hash on the data it has received. And then I'm hacking a few stat fields like modification time, creation time, and stuff like that. And I'm performing bit operations on these fields to store the hash. And thanks to the accurate mode, if the hash is different, then these fields will be different. And Bareos will tell the plugin, yes, give me this file because it has changed. So it's a bit hacky, but that's how I was told that it could be implemented.
But this would require that for an incremental backup, you always has to read the full disk of the in Incus?
Yes.
Okay.
The export is a full export. So for virtual machine backups, I would recommend the file daemon to be on the Incus host, because it will then be streaming the backup tar within the host, and it will just discard the data that's not needed. So the long-term goal is to use a very new low-level API that was released in Incus like 2 months ago, using NBD. So that allows to directly ask the virtual machine manager which blocks have changed, and then we can just take these blocks and send them. But for now, it's not implemented because I started the plugin before that new API even existed.
Okay. Yeah. So if virtual machines are used in Incus, it's based on QEMU KVM, right?
Yeah.
And
yeah.
I think since some time there is this dirty bitmap feature, which is like change block tracking. And
yeah, it's a new thing that we have implemented in Incus. So the new API came also with support for these dirty bits. The problem is that if you stop the VM, then these dirty bits just disappear. So that's the problem with QEMU. You can track the dirty bits only on running instances.
I see.
So storing these dirty bits over time is a little risky. That's not something that we are doing, because if you miss something, if you miss 1 byte, you can just end up corrupting your whole disk, which is probably not a good idea. So the support is still it's still early support for us. We would really like QEMU to extend its support for dirty bitmaps, but yeah, for now it's it has the same limitations at what you can expect from QEMU, and yeah.
Yeah, I see. Thanks. Okay, then